All right, today we're diving into something pretty huge in the world of computer vision. It's called YOLO11. It's from Ultralytics, and it's a new AI model that is totally redefining the balance between speed and accuracy. So let's get right into it and see what all the fuss is about. You know, it's a question that sounds like it's straight out of a sci-fi movie, right? How do we actually teach a machine to not just look at a picture, but to understand it? To identify a car, a person, or a specific sign, all in the blink of an eye? Well, a huge part of the answer lies in models just like YOLO. And that name, YOLO, it's not just catchy, it literally tells you its secret sauce. You only look once. See, older models had to scan an image over and over again, but the YOLO family was built for pure speed. It glances at the whole image just one time to figure out what's there and where it is. I mean, this was a total game changer, and it's the very foundation we're building on today. And speaking of that foundation, that's exactly where our story picks up. Building on years and years of innovation, Ultralytics has just dropped YOLO11. Now, this isn't just some minor update. We're talking about a genuine leap forward, one that's really setting a new benchmark for AI vision. Okay, so what's the big deal with YOLO11? What makes it so special? It's not really one single thing. It's a combination of improvements that make the whole model smarter, faster, and way more efficient. Let's break down what really sets it apart. So, at a glance, we're seeing much better feature extraction. That means it's better at picking out the important stuff in an image. It's been totally optimized for raw speed, and it's flexible enough to run on anything from a massive cloud server to a tiny little device. Plus, it can handle a whole range of different jobs, but the one feature that really makes you go wow is this: getting way more accuracy with way fewer parameters. Seriously, this right here, this is the holy grail for anyone developing AI models. It's actually not that hard to build a gigantic, power-hungry model that's super accurate. The real magic, the real genius, is making a model that's smaller, more efficient, but somehow even more accurate. And that's exactly what Ultralytics nailed. And look, we've got the numbers to prove it. Think of parameters in AI like neurons in a brain. The more you have, the bigger, slower, and more power-hungry the model usually is. The medium-sized YOLO11 gets better accuracy while using 22% fewer parameters than the model that came before it. That is a massive gain in efficiency. It's what lets AI vision run on your phone without killing the battery, or on a factory camera without needing a supercomputer. Which, of course, brings up the million-dollar question, right? How on earth do they actually pull this off? Getting more out of less isn't easy. It's got to be more than just a simple tweak. There must be some serious innovation happening under the hood. Okay, so let's pop the hood and take a look at the engine here. See, these kinds of gains don't happen by accident. They come from some really clever architectural changes that completely rethink how the model sees and processes information. Now, the research papers get pretty technical, but these are the key pieces of the puzzle. You don't have to be an AI wizard to get the big picture here. You've got these new, smarter building blocks like the C3K2, you've got souped-up components like the fast spatial pyramid pooling, and then this brand new C2PSA thing. All of them are working together to basically give the model superpowers in finding the important details and doing it super efficiently. Okay, that's the theory, and it sounds great on paper. But the real question is, do these fancy new parts actually make the car go faster? Let's look at the numbers and see how it really performs when the rubber meets the road. First up, the bread and butter of computer vision, object detection. You know, just finding stuff in a picture. So what you're seeing here is that classic balancing act between accuracy and size. On the left, you've got MAP, which is just a score for how accurate it is. Higher is better. On the right, params tells you how big the model is. Lower is better. But zero in on that YOLO11M model in the middle. Look at that, a really solid 51.5 accuracy score with only about 20 million parameters. That is the efficiency we've been talking about, right there in black and white. But hey, finding boxes around things is just one trick. Let's push it a little harder with instance segmentation. This isn't just about finding an object. This is about tracing the exact outline of an object, pixel by perfect pixel. Much trickier. And what do you know? That awesome performance carries right on over. It's still great at finding the object. That's the MAB box score. But now you see it's also fantastic at drawing that perfect outline, the MAB mask score. This just proves that new architecture isn't a one-trick pony. It's genuinely robust. These numbers are awesome, for sure, but they're not just for bragging rights in a research paper. The whole point is to get this power into the hands of people who build things. So, what does it actually feel like to take this out of the lab and into the real world? And wow, this table just says it all, doesn't it? I mean, whatever you need to do, find objects, segment them, track a person's pose, even classify an entire image. There's a YOLO11 model for that. It's like the ultimate Swiss Army knife for computer vision. And maybe the best part of all of this insane power is ridiculously easy to use. With just a couple lines of code, whether you're a Python person or you live in the command line, you're up and running. This is how you democratize cutting-edge AI. So, let's bring it all home. What are the big things to remember here? First, YOLO11 completely changes the game when it comes to balancing accuracy and efficiency. Second, it's incredibly versatile, handling almost any vision task you can throw at it, all thanks to those clever new architectural designs. And finally, and this is huge, it's built to be dropped right into real-world projects. And all of this leads to one final, really exciting question. Now that we have AI that can see this well, this efficiently, on pretty much any device, the only question left is, what are we going to build with it next?